back to askIITians. In the previous lecture, I told you what do we mean by system, surrounding and the basic parts of thermodynamics. So in today's lecture, I'll be telling you what are the different kinds of processes which are associated with thermodynamics. We'll try to discuss about different kind of processes including adiabatic, isothermal, isochoric process. So let's start with the session so that you can understand the different kind of processes. Now moving over to another topic, let us start discussing something about thermodynamic processes. Now as per I have told you in the very first line that once we are done with something which is known as system, surroundings and boundary, we'll come over to what do we mean by the term thermodynamic processes. So let me first of all define what do we mean by a process, and I will simply say that any path along which the state of the system changes is known as a process. Now, to define what do we mean by a process, we should know first of all what do we mean by the state of a system. Let's take into consideration, for example, you have a beaker in which you have kept some water. Now, you have enclosed this beaker with a piston arrangement. That means you can either move the piston up or you can move the piston little down. Now, what are the pressure, volume and the temperatures of this system as a whole at any particular point of time? This is what is known as state of the system. Now we know what is the state of the system. So this is at, for example, time t1. Now let me do a process over the system like I am trying to push the piston little downwards. Now if I am trying to push the piston little downwards, that means the system is going to change from state 1 to state 2. So this path along which the state of the system has got changed, this is known as a process. Now once we know what do we mean by the term process, we can define what are the different kind of processes which we are going to study in thermodynamics. So the first process that we are going to study in thermodynamics is known as isothermal process. Now iso means same, and isothermal, since it is comprised of two words, so iso means same and thermal means temperature. So those processes which take place at constant temperature, like for example, I am trying to move the system from, let's say, a state P1, volume V1, temperature T1, to I am trying to move it to another state where, let's say, the pressure is P2, volume is V2 and temperature is T1. So during this process, the temperature of the system didn't change, and hence this kind of process is known as isothermal process. Let's move ahead to another type of process which is known as isobaric process. Again I'll say iso means same and baric, since bar is a unit of pressure. So any process which takes place at constant pressure, let's say for example I'm moving from pressure P1, volume V1 and temperature T1 to pressure P1. Volume suppose have changed to V2 and temperature has got changed to T2. So going from this state to this state has followed an isobaric process. Now let me move ahead to isochoric process. Iso means again the same, choric means that the constant volume is to be maintained. So once you are suppose say going from P1, V1, T1 to let's say P2, V1, T2, so where the volume of the system has been kept constant. So that kind of process is known as isochoric process. Having done these three simple kind of processes, we come over to adiabatic process. Now what do we mean by adiabatic process? An adiabatic process basically means any process where the transfer of heat cannot take place between the system and the surrounding. We have discussed this thing, right, that there is a system and the outside is the surrounding. So whenever heat change are taking place between the system and outside the system, that means that kind of processes we are going to study. But suppose if I have maintained a condition, the boundary, the wall I have taken is such a kind of boundary which is non-conducting to heat. That means neither the system can get heat from the surrounding nor the system can give heat to the surrounding. Such processes are known as adiabatic processes.